Welcome back. In this lesson we're going to learn about the volume and surface area of prisms and cylinders. So first I want to talk about just the surface area. We learned in the last chapter how to find area of a lot of different shapes. So there's no new shapes that we're going to find area of. There's just maybe a little bit different of a method. So we have a three-dimensional figure. We'll take a look at this prism over here. We have a three-dimensional figure like this one. And we want to find the surface area of it. We want to find the area of all the shapes that cover this prism. So on the front here, we would need to find the area of this base. I'm not going to go through the process of doing that because we learned that last chapter. But we would need to find the area of that base. And there are two of those bases. We have one in front and we have one behind. So we would say the area of the base times 2 because we have two of them. And then we have our faces, right? So we need to find the area of the face, which in this case is a rectangle. You guys all know how to find the area of a rectangle, base times height. And in this case, we have how many faces? It would be the same number of sides in our base. So we have 5 faces. So we can multiply that by 5 once we figure out the area of that face. So we figure out those areas. I get some values. And then we can total them up to find the total surface area. So that's just the area of every shape surrounding my prism. Same thing goes with the cylinder over here. On the cylinder, we have circle on top and on bottom. So the area of a circle, let's see our bases, we would use the formula pi r squared, right, to find the area of a circle. And then since we have 2 of those, we'd multiply it by 2. Now, the face of this, we have to use our imagination a little bit. So if I had a can, and let's say it doesn't have a top and it doesn't have a bottom, we just have our face here. And if I cut down the face and open it up and peel it back and spread it and lay it down flat. So I cut it open and lay it down flat. Think about what shape that would make. And you should hopefully imagine that it is a rectangle. So any cylinder, if we cut it down like this and stretched it out and laid it flat, it would make a rectangle. So we know that the area of a rectangle is base times height, right? So we know the height right here, but the base would be the circumference of this circle. So if I lay this down flat, the base would be the circumference of that circle. So we could say it is 2 times pi times the radius times the height to figure out that face. The height is here, and then the base of my rectangle is going to be all the way around the shape, which is the circumference. And we only have one face here, so we're not going to multiply that by 2. So then if we add the area of our bases and the area of our face, we would get our total surface area for that cylinder. Alright, so now on to volume. Volume is really easy. If you guys understood area well, then volume should be a breeze. So volume, all we have to do is a formula for volume of a cylinder, and all it is the area of the base times the height. So that is the volume of a cylinder. All right? So let's do a little problem together. We'll say that this cylinder has a radius of 3 and we'll say it has a height of 10. Okay? So the area of the base, this has two bases, right? And they're both the same, so we just need to find the area of one base. The formula for the area of the base is pi times the radius squared, because this base is a circle. So if we want to find the area of the base, we use the area of a circle, which is pi r squared. Now we need to multiply that times the height. So if I plug in all my values, pi times 3 squared times 10, I get, let's see, 3 squared is 9, 9 times 10 is 90, so I get 90 pi. If the problem says to leave it in terms of pi, then we would want to leave it like that. If not, we would want to get out our calculator, and we can put in, maybe, 90 times, pi. And we get 282.743. All right. 282.743. All right, I'm going to put some units on this now. So let's say this is 3 centimeters, this is 10 centimeters. Units with volume is cubed, or cubic, as you can imagine, because it's three-dimensional. So we have cubic. So always the units in volume are going to be to the third power. All right, let's do another shape here, the volume of a prism. So the volume of a prism is the exact same formula. Area of base times the height. All right. So area of base times the height. Now this prism, we have a base here of a pentagon. So pentagon is a little more lengthy process. I don't have any units on here. Let's say that this side is 4 centimeters. And we'll say that the height here of our prism is 5 centimeters. All right. So let's go through the process of finding the area of our base first. So the area of our base, remember that we need to make this polygon, cut it into triangles, right triangles. So if this is 4, then my triangle here, that'll be 2. So let's draw this out to the side here. It's not very good. It's a little bit better. All right, so that is 2. First we need to figure out what this angle is here. So we can figure out that angle, remember, because this is 360 degrees around here. And we can divide our 360 degrees by the number of little triangles we have here to get this angle. So the number of little triangles we have in this shape is going to be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 360 divided by 10, which is equal to 36. So this angle is 36. So we need to find the area of this triangle. And then once we find the area of our triangle, we can multiply it by 10 to get the area of that whole base. So the area of a triangle is 1/2 base times height. We have the base 2, but we don't have the height. So to find the height, we have to use SOHCAHTOA. Hopefully you guys become experts at this now. And know the equation we need to write out is the tangent of 36 is equal to 2 over x. Now when you get this variable out of the denominator, so we multiply by the variable, and we get x times the tangent of 36 is equal to 2. Then to solve for x, we need to divide by the tangent of 36. So we have 2 over the tangent of 36 is equal to x. I'm going to plug that into my calculator. 2 over the tangent of 36. Let's get the calculator out. We have 2 divided by trig. Tangent. Oh, did something weird here. Let's try this again. 2 divided by the tangent of 36. That looks good. And we want the answer. So we got 0.26, we'll say. All right. Let's look at our picture and see if that makes sense. 0.26 for this side. I don't like that answer. I think that this height here should be higher than my base, should be a larger number than my base. So let's look and see if we did something wrong. We have 2 over x multiplied by x on both sides, divided by the tangent of 36. Let's go back and look at the calculator. 2 divided by the tangent of 36. I'm thinking that maybe we're not in the right mode. So let's check that. Go to Documents and Settings. Settings. And Document Settings. And look right here, angle, it says radians. I don't know how it got into radians. So let's change it to degrees. Always, if you get a weird answer when you're doing your SOHCAHTOA, you can check that. And we'll make that default, and hopefully it stays that way. And if I hit enter again, oh, get a crazier answer. Let's see, we have 2.75, which makes more sense. I like that answer better. So height is 2.75. Didn't write out very well. I'll write it over here. So 2.75. All right, so now I am going to use that in my area formula. Say area is equal to 1/2 2 times 2.75. I can do that in my head. We have 1/2 times 2. 1/2 times 2 is 1, and 1 times 2.75 is 2.75. All right, so now we need to multiply that by the number of little triangles we have here. And we said that we had 10. So if I multiply that by 10, I get 27.5 centimeters squared for my shape. All right. So that is the area of the base, which I'm going to use right here. So VP, the volume of the prism, is equal to 27.5 centimeters squared times the height, which is 5 centimeters. So we have 27.5 times 5. We'll use our calculator for that. 27.5 times 5 is equal to 137.5. So 137.5, and that's centimeters cubed. Notice that we have centimeters squared. We have centimeters squared for the area of the base times the height, which is centimeters. So that's where our centimeters cubed comes from. When we combine the centimeters squared and another centimeters, we get our centimeters cubed. All right, I hope you enjoyed the lesson. Bring any questions you have to class. See you there.